So today we will be learning how to divide polynomials. We will start with a basic introduction on the topic. Now to do this process, which is a very easy process, mind you, once you get the gist of it, it's the same for every single expression, so you should be able to do it. Now in order to do this, we need to look at the steps involved. Now I could read these out to you, but I'm thinking I'll do that while we're actually going through the visual example I have prepared, so it will make more sense. So let's take this example. It's a very easy example, 3x minus 5 divided by x plus 2. It's a very easy example because you do not have difference of bases, meaning you don't have, for example, a quadratic expression all over a linear expression, or maybe even a cubic expression. In this case, we have two linear expressions, meaning x to the power of 1 divided by each other. So, create this diagram. It's basically the basis for long division. And we need to put our terms in their proper places. The numerator, you would put it on the right-hand side, so 3x minus 5, and the denominator on the left-hand side, x plus 2. Now, step 1 would be to divide the first term of the numerator, so 3x, by the first term of the denominator, and place a result on the top of the right-hand side. So, 3x divided by x is 3. Place that there on the top. Step 2. Multiply this result by whole denominator. So you have to multiply 3 by x plus 2 and place the result at the bottom, meaning beneath 3x minus 5. So 3 times x plus 2 is 3x plus 6. You place that there. Now you subtract 3x minus 5 by 3x plus 6. And we do this in order to cancel out the 3x. So 3x minus 3x would be 0, and minus 5 plus 6, minus 5 minus plus 6, that is, minus plus becomes minus, so it's minus 5 minus 6, you get minus 11, negative 11. Now you repeat steps 1 to 3 until the denominator is larger than the subtraction result. Now in this case, we don't have to repeat the steps because we've already achieved this condition, considering that negative 11 doesn't have another term with x to the power of 1, so we don't have to divide anything anymore. It's lower than the denominator. So in such a case, now that we've done this, what would the final result be? What is the end result of dividing this polynomial? Well, before that, we have to understand which parts actually go in to the final answer. We need to take the part on top, 3, and the part at the bottom, negative 11, for our final answer. And these two values have names. 3 would be the quotient, and negative 11 is the remainder. Therefore, the answer would be like this. You have 3 plus minus 11 all over the original denominator x plus 2. And you know plus minus is minus, so it's 3 minus 11 on x plus 2. But this might be a bit of a peculiar structure for an answer in algebra. But we can feel a bit comfortable knowing that every single answer in dividing polynomials tends to, in fact, be identical to this general model. So we can extract a formula from this answer to understand or get a brief idea as to how each one of our answers will end up looking after we divide polynomials. And the general formula is as such: the quotient plus the remainder all over the original denominator. And this makes sense. We have the quotient, represented by 3, plus the remainder, in this case it's minus 11, and so plus minus 11 is just minus 11, because plus and minus make a minus, all over the original denominator, which in this case was x plus 2. So that should serve as a brief introduction on how to divide polynomials. We shall build on this general idea later on in another lesson.